Okay, our group did limits, and this is Andy Najat, Kate Furster, and Nicole Flutterick. So to begin with, a limit is the height or y value as x approaches c. And there are two ways to calculate a limit. You can either do it by graphing it, which would give you a visual image, or you can calculate it. And we're going to be doing calculating. So one of the formulas you're given is the limit of f of x as x approaches c equals L, and L and c are real numbers. Also, take note, this is very important, that f of x as x approaches c never depends on what happens when x equals c. It's not at the point, it's at what's leading up to the point. Okay, and to give you a problem of this, we're going to take this equation, f of x equals x minus 3. So you're looking to find the limit of f of x as x approaches negative 2. And now to solve this, you're going to plug in negative 2 for x minus 3. So this is going to be equivalent to negative 5. Okay, another problem is going to be more in depth. So you're solving for the limit of f of x as x approaches negative 3. 2x cubed minus 7x squared minus 33x plus 18 over x squared minus 9. So eventually you're going to end up plugging in the negative 3, but it helps to take things out. Bad factors, we call them. So limit x approaches negative 3. Always make sure you write your limit. So you factor it out to x plus 3, 2x squared minus 13x plus 6 over x plus 3, x minus 3. So now these two cancel out. So now you're left with the 2x squared minus 13x plus 6 over x minus 3. Now you can synthetically divide. So you're going to take your negative 3, you take 2, minus 7, minus 33, and 18, if you remember how to do this. Okay, and then you're going to bring down your 2. 2 times negative 3 is negative 6. Add those together, and you get negative 13. 13 times negative 3 is 39. And then if you add those together, you're going to end up with 6. 6 times negative 3 is negative 18. You take that out, you get a 0. Factored, so you're left with 2x squared minus 13x plus 6. And this is going to be over your factor, which is x minus 3. So now you're solving for your limit as x approaches negative 3. What is that? And to solve for this, you're just going to plug in your negative 3 like you did in the previous problem with where the answer was negative 5. So once you plug in negative 3, are going to get which equals negative 10.5. Okay, now Nicole is going to take you with the rest. Some trigonometric equations for you to know. The limit of theta as it approaches 0 of sine of theta over theta will always equal 1. and the limit as x approaches 0 of 1 minus cosine of x over x equals 0. So an example for that would be the limit as x approaches 0 of sine of 2x over 2x is equal to 1. Since the 2x is the same as the equation before, it means the same exact thing. It's just sine of x over 2x instead of sine of theta over theta. In a similar sine equation, you have the limit as x approaches 0 of sine of 2x over sine of 3x. Since the numerator and the denominator don't equal the same thing, like the theta over theta, you have to multiply the top and the bottom by 6x to make it look like the equation we are given. You also have to break this into two separate equations. To get the numerator to look like the top equation, you would have to make it into 1/3 times the limit as x approaches 0 of sine 2x over 2x. And then the second half of that equation would be 2 over 1, or just 2, times the limit as x approaches 0 of 3x over sine of 3x. Since both of those just equal 1, it ends up being 1/3 times 2 over 1, which is equal to 2/3. So for limits that have infinity, you have to look at the equation. If the equation has an exponent in the top that is greater than any in the bottom, it goes to infinity. So for an example, as the limit as x approaches infinity of 2x squared plus 7 over 5x minus 1. The limit would equal infinity because the numerator has an x squared in it and the denominator does not have any variable with an exponent. Now, for the opposite of that, for the limit as x approaches infinity of 2x minus 5 over 3x squared minus 8, the limit would equal 0 because the variable with the higher exponent is in the bottom. So it would be approaching 0 instead of infinity. Now, if the exponents are the same for both the numerator and the denominator, then you would use the leading coefficient of those two numbers to get your limit. An example would be the limit as x approaches negative infinity of 2x squared minus 3x plus 1 all over 5x squared plus 8. Since the two variables have the same exponent, they both have an x squared in them, you would use the leading coefficient of both of those numbers for the limit. So the limit for this problem would be 2 over 5. And there it is. is written out right here. Degree in numerator is greater than degree in denominator. There's no asymptote. Degree in denominator is greater than degree in numerator equals 0. And the degree in the numerator is equivalent to the degree in the denominator. It's your leading coefficient, which is what Nicole just explained, but just isn't a visual for you to see that.
The exceptions to this are exceptions. It's a C. The greatest integer function jump discontinuities oscillating asymptotes asymptote, which will appear like this, or many other ways, but here's one. And removable discontinuities. So pretty much a whole.